Good afternoon, hello, and welcome. My name is Everett Cardy, and this is the third episode of Math and Algebra video tutorials, where there's a concept, a vocabulary term, and problems. These videos are math-antic videos for dummies, supposedly, if you've ever read the books, typing for dummies, programming for dummies, all those kinds of things. Now, the expectation for anybody watching these videos is to have a basic understanding of single-digit and multi-digit addition, subtraction, division, and multiplication problems. If you know how to do those problems, you're good to go. Today's topic is acronyms in math. Acronyms prove very, very useful in other areas of life, and they're very common. And they're used to shorten things like ASAP. And it's supposed to make a word as soon as possible. It's an expression. They prove very useful in math for breaking down and outlining the steps and the order to go through of long, drawn-out, complicated, difficult, forgetful problems. That can be very confusing if you don't have, something like an acronym to make it easier. So we're going to be looking at that, but before we do, we're going to be taking a look at exponents. This is what an exponent looks like, if you can see it. I'm actually going to move this over here so that you can see the board. Okay, stay. So you have your number, your regular number, and then you have a little number up at the upper right-hand corner. What does that mean? What is that little number doing up there? Do I have to add 3 plus 2 to get 5? Do I have to subtract 3 minus 2 to get 1? Multiply those to get 6? Or divide them to probably get 2.5? The answer is neither. Neither. You have this number here. You have this little number here. Now, this is the number that you were multiplying by. And this is how many times you're going to multiply this number. And you can do this easily on a calculator. So, timesing is the rule. So, multiplying. So, we take 2, we times 2 3 times. This is what this means. So, 2 times 2 times 2. And no, this is not an exponent. So, this is kind of getting into what an order of operation problem would look like. So, we go from left to right. Remember looking at the number line? Our eyes go from left to right. And that's really how, one of the ways to solve order of operation problems already. So, we take 2 times 2, which would give us 4, and then we draw the line, and then we drop down what is left of the problem. We still have that times 2, so we drop that down, and then we draw another line, 4 times 2, would be 8, and that is the final answer. If I can draw a backwards, upside down triangle around the equation, then I've done it right. I'll write that out again. Another one would be 4 to the 5th power. And that would equal 4, 1, 2, 3, 4, 4. So 4 times 4 times 4 times 4 times another 4. So 4 times 4, bear with me, is 16. And then we have to drop everything else down. 4, let's see here. So we already have 2 4s. 4, 4, and then 4. So 16 times 4 is 64. And then we have 2 times 4 left. So then 64 times 4 would be 16, 24, 25, 256. And then times another 4, which is the final 4. Would be 20, wait, no, 24, excuse me, 20, 21, 22, 8, wait a second, the 24, 20, then 8, 9, 10. 1024 would be the final answer. And then we draw backwards triangle around that answer. Or the equation that we're using. If you have, say, a number in parentheses, 5 in parentheses, but what if we had an equation like 5 plus 6? No, well, you just solved that 6, 7, 8, 9, 10, 11 in the parentheses, but you would not have a parentheses around the answer. You would get rid of the parentheses. So and you do that for the other 4 operations. So all of that knowledge is it is essential for understanding the acronym that we're going to get into. I just want to, I don't walk well. I'm trying to find, why do I do that? Okay, that doesn't work. Melanie. No. This has to work. Okay. I feel like I'm using up all my markers too quickly. So the word is PEMDAS. PEMDAS. Oh. Well. So this is the word. You can add an extra S to it, but you don't need to. So this is the acronym to use for solving order of operation problems. Another way that you can remember is, please excuse my dealing at Sally, but I use this. This is what an acronym is. It makes a word, and it has, letters that stand for a word. And then, all those letters are put together, beginning of the word letters put together to make a word here. So this lays out the steps in order of how to solve order of operation problems. So let's look at what these all mean. P stands for parentheses, and I'm not going to write it out because it's going to take too much ink and a little bit more time. E stands for exponents, so 2, say, 2 to the 4th power. M and D. M is multiply, D is division, A and S, add, subtract. Big or smaller, and then right over there. So this is all the steps in order of how to solve these problems. We don't need to worry about decimals, because that's not a D in there. I'll leave that up for you to see. So let's start with 1. So 5 plus 7 minus 6 times 2 plus 9. And I could do smaller ones, but I want you to basically understand just the steps. So there's, a million things that I could do, but I'm doing this one. That's the point. So, following the order of PEMDAS, we obviously would start out with the P. You don't read words backwards. You read words from left to right. So we start out with the P, which is the parentheses, hence the little picture right there. So what is in the parentheses? 7, 8, so 5 plus 7. 7, 9, 11, 12. The answer doesn't need the parentheses. You drop the 12 down, and you have to drop everything else down with it. And then now we cross the P out. So, let's write it downhill, I guess. So we cross the P out, so we check the P off. We've dealt with the parentheses. Now, what about exponents? I don't see any exponents here anywhere, so we don't need exponents. Now, what about multiplication? Oh, I see a multiplication problem right here. So 6 times 2 is 12. And then drop everything else down. And then, it has to be the steps exactly. It has to be the steps exactly. So, there's no division here, so we can cross that off. What about adding and subtracting? Well, there's an addition problem, 12 plus 9. 12, 13, 14, 15, 17, 18, 19, 20, 21. And then we drop down minus 12 here. And then 12 minus 21, or that's how we do it. So 12 minus 21, 1, 1. So answer would be 11. So, if I can draw that same backwards triangle around the problem, then it's right. So let's do another. Okay, we have this problem right here. We have this equation. So, following PEMDAS, following what we need to follow. So, looking here, are there any parentheses? Yes, there is a parentheses. So we solve 9 plus 8, 19, 11, 12, 13, 14, 15, 16, 17. Don't even need the parentheses. And then if there is a number right next to the parentheses, that would mean that we would multiply. Okay, so now we have got the parentheses cleared out of the way. So, now we look for any exponents is the next. So we cross this off. Any exponents? Yes, I see exponent here. So 5, and then you have the little, 2 up there. So 5 times 5, taking 5 twice would be 35. No, that would be 25. Okay, I'm losing my mind here. So 25. We drop everything else down. So now we cross off exponents. Now what we have left is MDAS. So now we're looking for multiplication. Any multiplication? Yes, there is, and it's gonna look confusing. So when you have two equations with two numbers in each equation that are solving for the same thing, we would move from left to right. So 17 times 2, 14, 2, and then 3. So 34, and then we still have that times 17. So that's going to take a little bit of time. So 28, 21, 22, 23. Here, got the 0 down, 4, 3, and then plus 2, 5. Then we add these 8, 4, 5, 6, 7. 5, 6, 7. And then we get Then we just drop that same sign down to 778. And then we still have this left, so we drop that down here. So, now we still have this left right here. We still have more multiplication. So we need to times that, and I'm going to be right back. So we take 34 times 778. Okay, let's do that again. So take the bigger number, 778 into 26452. Okay, I need to do that again. I know why that. Okay, this is ridiculous. Okay. 778. And then we have this answer, so that equals 26452. Then we drop down 3 plus 25, and then we have this left. So now we're coming to the final stages of the problem. So following this order, we don't have any division, so we check that off. Then all we have left is adding and subtracting. So we add 25 plus 3 because it's over here. 25, 26, 27, 28. And then we subtract that by over here. So 26452. I need to do that on the calculator here. And that would be 26424. And that would be the answer to that. So, that is it for today, everybody. I hope that you found this informative. Now, on the next video, we're going to be looking at types of numbers.